Hi guys, today we're going to further investigate the symmetry properties of the unit circle. So we've already looked at some of the symmetry properties. Let's continue with that. What we can see here is a black triangle, which I have the angle theta, and then a red triangle, which I've labelled as negative theta. So if theta was 25 degrees in the black triangle, in the red triangle it would be negative 25 degrees there. So with this triangle, we can see that cos of negative theta, so the x value of your red triangle, will be the same as your cos value or x value of your black triangle. So cos of negative theta is the same as cos theta. For sine of negative theta, that's the sine value or the y value of the red triangle. Well, that's going to be the same of negative of the sine value of your black triangle. So just say the length of your sine in the black triangle was 0.6. Well, then in your red triangle, your sine value would be negative 0.6. For tan of negative theta, it's going to be negative sine theta over cos theta. So it's going to be negative tan theta because negative divided by positive is negative. Let's now look at this triangle here. I've labelled the x value A, or the cos value, and the sine or y value as B. So there's sine theta, which is B, and here's cos theta, which is A. There it is down there. So let's remember that. Here's the unit circle here, and add pi on 2. That's a quarter of the way around the circle. Remember that the whole circle is 2 pi. So 2 pi divided by 4 will give us pi on 2. Let's look at sine pi on 2 minus theta. So theta in the little unit circle down the bottom, remember we've said that sine theta is B and cos theta is A. Let's draw that in there. So let's now take that theta and put it so that the triangle looks like that red one there. So the B value is now going to be at the top. So it's going to be our cos value, and A is going to be our sine value. So the angle here, which is pi on 2 minus theta, so it's the quarter of the circle minus that theta. There it is in there. As you can see, your A value, I've marked it in blue. It's the same on both those sides there. Meaning that pi on 2 minus theta, or sine of pi on 2 minus theta, equals A, which equals cos theta. Because cos theta, as we can see from the little unit circle on the left, is the same value, it's A. And that is A now, which is sine pi on 2 minus theta. Cos pi on 2 minus theta is going to equal B, which is sine theta. See how that works? We've taken that triangle from the left-hand side in the little unit circle, and by putting it up there, it means B becomes our cos value of pi on 2 minus theta, and A becomes our sine value of pi on 2 minus theta. Let's try this one. So here, I now have pi on 2 plus theta. Let's think about the sine value there. Here we go. We go all the way around from 0 to pi on 2 plus theta. There it is in there, that's that angle. So the sine of pi on 2 plus theta is going to equal A, which is cos theta. The cos of pi on 2 plus theta is going to be our x value. You can probably already see that that is going to be negative B. Look at where the B is at the top there in our red triangle. It's in the second quadrant, and in the second quadrant it is a negative value. So it's negative b, which is negative sine theta of our original triangle over here. Let's have a look at this. Bit of an example. If sine theta equals 0.3 and cos alpha equals 0.8, find the value of sine pi on 2 minus alpha. So let's draw it there. We've got the unit circle and we've drawn a triangle with alpha in there, and the cos alpha is 0.8. So that means the x value is 0.8. There it is illustrated there. There's pi on 2. I've kept that unit circle in the left. You can see it there in the bottom left. Alpha angle, 0.8 being the cos value, and pi on 2. Now, let's now take that alpha, so the same angle. Let's put that triangle in that position. Now, we can see that our sine value is going to be 0.8. The angle is made from 0 up to where alpha is. So it's pi on 2 minus alpha. 0.8 is our sine value. So sine pi on 2 minus alpha is going to equal 0.8. Let's now do the value of cos pi on 2 plus theta. Here is theta, and we're saying that the sine value of theta is 0.3. So that's how we would illustrate it there. There's pi on 2. Let's put that triangle down in the left-hand corner, and let's now move the triangle so that we're saying pi on 2 plus theta. There's the triangle there. Where is 0.3 going to be? There it is there in blue. So there's our angle of pi on 2 plus theta, and the value of cos is going to be the same as what sine used to be when we had theta in our triangle on the left-hand side. That length is 0.3, but because it goes in the negative direction, it's in the second quadrant, it means that cos pi on 2 plus theta is going to equal negative 0.3. Now let's see if we find sine of negative theta. So there's our unit circle, there's the triangle with theta, and we know that sine theta is 0.3. So our y value is 0.3 for that particular angle value. Let's put that triangle on the left-hand side, and let's move that triangle to the negative. So we're saying sine of negative theta. There's negative theta there. So it's the same, it's just gone into the fourth quadrant. The sine value is going to be 0.3. There it is there. It's still a length of 0.3, but look where it is. It's in the fourth quadrant. So as you can see there, we're in the negative zone for the y-axis. So therefore, sine of negative theta is going to be negative 0.3. And that's all for the further properties of the unit circle. The next one that we will do will be looking at the table of exact values.